Yeah, so fire is the number one problem in a data center. So it destroys a lot of our millions that we had invested in. So that's why it's the number one enemy. Remember also we're dealing with a lot of power, there's electricity, so there's highly likely to have a fire in a data center. And all our servers in the data center, they create a lot of heat, which also can be a fire risk. And our breakers as well, switchboards, there's a high risk as well of fire coming out of them since you're switching high currents. And UPSs, they can blow up too because there's electronics. And so will go down, fire will go down as the number one cause of a loss in a data center. And also UPS batteries, remember batteries also, they do thermal runaway, so they can cause as well a fire. So that's the reason why fire is a number one hazard in a data center, and it needs its own time to be studied, right? But it's not a very long topic. It's a very short topic for the fire. Just I'm going to point you out, guys, to what's needed and what's not needed. So as we start now, we need to monitor our data center and see if there is a potential of a fire or if there is a fire that already started. So to do that, they came up with a fire monitoring system, right? So I want you guys to always remember this. There's two things. There's fire monitoring system and there's a fire suppression system. Those are two different things. Understand, guys? Understand this, guys. You can have both of them in one, or you can have only one. So for most places, if you go in your house, you'll find that there's a smoke detector or heat detector. That's just a fire. That's a monitoring system because it just alerts you to tell you there's a fire in this place. So I just wanted you guys to know this because often than not, people mix the two. So that's the reason why I had to put it out there. So the fire monitoring system is the first topic we are starting with. And in the fire monitoring system, it's comprises of three, right? So like I said, it just alerts you that there's a fire somewhere, that it started somewhere, right? Alerts you in certain ways. One, by bell. Two, by a siren. Or three, it can also place a call to, depending on the system, it can also be programmed to place a call to the nearest fire station. So that's the third way of alerting people that there's a fire. So there's these fire monitoring systems. They have three main components, right? So these three main components are divided into three categories. So this is what you need to know mainly, that they are input components, right? The input components are the ones that detect a fire. You understand? The inputs, they detect a fire, right? So in this, you have things like smoke detectors, the one we spoke about, the heat detector as well, and we have carbon monoxide detectors. We have the manual pull, the one that you press. If you see a fire somewhere, you can press it. It also counts as a input device because you press it, then it all sends now to the central processing unit, which is just the brain or just the process, I can call it in term, or just control unit, right? And the control unit is going to now send signal to say, okay, let's ring a bell, or let's ring a bell in the siren, or let's do all the three, ring a bell, ring a siren, and send a signal to the nearest fire station. So I want you guys to know this stuff. So a bell or a siren or the output signal to the nearest fire station, or a signal to the, which I'm going to cover later, a signal to the fire suppression system. So this is what we're going to be asked about. And on the, you're going to be asked as well on explaining the different fire, the smoke detectors, right? How do they do it, right? The first one, which is the easiest one, is ionization, right? Ionization, remember, process of ionization, right? It's just two in electronics. Remember, there's diodes, or there's diodes that operate using ionization. So if dust gets into the chamber, it's going to increase the resistance between the two plates that are ionization is taking place. And once it senses that resistance, it's going to send an alarm to say, oh, so it can be dust or smoke, which is the main disadvantage with smoke detectors. We're going to talk about that. So forgive me, I'm going to mention this stuff as fast as I can. So the main disadvantage with most of smoke detectors, especially this one I just mentioned, which is fire, it doesn't know which one is dust, which one is smoke, of which dust is dust, can happen and doesn't cause us any danger, but smoke can cause us danger, right? So that's why I need to put it out there. Then there's the light obscuring, right? The light obscuring, just two diodes that are facing each other. So there's a sender and the receiver, which are facing each other. But this stuff you can see on the pictures. If you just check on different types of light, of fire, of smoke detectors, right? And once dust or smoke gets into the chamber and the light is not going directly to it, then resistance will gain on the one that is sending the light, and it will trigger also an alarm. So it just, again, the problem is it won't be able to differentiate between dust and smoke, right? And a lot of fire detectors can be triggered by dust, which is not a good thing. And the third one, which is light scattering, right? Again, receiver and sender and the receiver, two diodes facing each other. So obscuring can be a very big beam, right? That will be, and another beam on the other side. So this can cover a very large area, right? They use them in very big places like data centers, for example, right? And they cover a very big area. So one can be put 50 meters away, so pointing to the other. So if anything breaks the light from going from the sender to the receiver, then the resistance is higher, so it will think it's smoke, so it will release, right, the alarm to send the signal back to the processing unit, and the processing unit will send an alarm, right? So imagine if there's a lot of dust in the room, especially in data centers, there's a lot of dust, because air can come with a bit of dust as well. So you'll be running all day, right? That's the main disadvantage of this one, these smoke detectors. But please remember the types of smoke detectors. So there's only three, right? So the ionization one, light scattering, and the light obscuring. So it's all easy, but you just need to remember all those types of smoke detectors. Then we have, from there, we have heat detectors. Heat detectors, they work in such it's a solid. They use certain solids which are very sensitive to heat. So if temperature rises to a certain point, that solid will just melt down, right? And if it melts down, liquefies, then it will release. Then a contact is going to be made, and a signal is going to be sent. But those are all easy, simple things to explain. But questions normally come on the smoke detectors. So make a note there to always remember those 3 smoke detectors. Then we're going on the remember the processing units, right? There's one which is the conventional method. So these ones you may or you may not be asked about them, but you just knowing them is not bad, right? So there's the old one, which is the conventional one, which is the old school. So what they do is, you see, like we mentioned, the inputs, right? What they do is they put them in different locations, right? So in your building, let's say you have a building with 5 rooms, right? So you name each room 1, 2, 3, 4, 5, right? You know the numbers, right? After you do that, then you wire, you call them zones. So room 1 is on 1, room 2 is on 2, room 3 is on 3, room 4 is on 4, room 5 is on 5, right? That's zoning. That's what you do. So if an smoke detector detects that there's a problem in room 3, there's smoke in room 3, it's going to show on the processor that, yeah, you check there's smoke in the room 3, right? And it's going to be ringing a bell or something, right, to you. That's how they say. So that's the conventional method, the conventional one. It's normal. So you have to do physical wiring, right, to all these points. These are all fire detectors. So also, guys, you are free to tell me if I'm going too fast, because I think it's a very simple and short course. So that's why I'm going so fast. And we are going on the addressable one. So the addressable one is easy, that one as well, because I know most of you guys are doing PLCs and stuff, and the old type PLCs where they use what do you call them? They put addresses in deep switches. They use deep switches, right? So you put, probably to be having the addressable one, the processing unit will be having you give yourself each address to each and every input, right? Like a smoke detector, heat detector, any of them, you give them inputs, right? An address to say, okay, you are, for example, 0000, then in binary, of course. Then another one is 0001, another one 0010, for example, right? Naming them and changing the deep switches, name the addresses for each, so that whenever an address trips, this addressable processing unit will send an alarm, and at the same time telling you the exact address where this can happen, where the fire is, right? That's number 2, which is, I think it's easy, but most of these 2, they're not really used most of the time. So the other one is the most used one, is the intelligent one. The intelligent one, there is it's the most used one, because each and every input is intelligent, and this is where they develop the one they call, so you're gonna be hearing the word what they call it, VESDA, a lot. VESDA. So the VESDA unit, right? It's just an intelligence unit whereby all the fire inputs, right? Like the heat detector and the smoke detector will be in, most of the time, in one. It will be one doing both, right? Or also doing carbon monoxide mostly, right? It will be doing all those things, only one, right? That's why it's intelligent. So it's its duty now to sample the air, like the VESDA. What it does, it's constantly sampling the air. So if it's sampling the air and it sees that there's reduction in oxygen in the air, remember we have 21%, right? There's reduction in the air, right? It will also send an alarm, right, to say, oh, signal, hey guys, there's reduction in carbon in oxygen. Remember, fire uses oxygen, right? So if there's reduction in oxygen, it means there's a fire. You understand? And we also samples the air as well to see if there's smoke. So if it's dust only, Now, it will pick dust. That's why this intelligent one is the most common one now, because it can differentiate between dust and smoke, because it's always sampling the two. And normally it doesn't send an alarm until at least two of the inputs are triggered, right? At least two of the things. So there's reduction in carbon, in oxygen, and there's also or maybe increase in carbon monoxide. Remember, when fire is burning, most of the time carbon monoxide is being produced, and there's also some smoke. So it will pick that. That's where the intelligence comes in. So each and every input, right, is its own processing unit on its own, and it sends the signal back to the intelligent processor, which is going to do an action after receiving from that. So on its own, it has its own brain. That's the only difference you need to know. Then there's another one, which is, I don't really need to worry about it, but it's a wireless fire alarm, which uses there's no physical wiring of inputs and outputs. It just uses Wi-Fi. So nowadays they're using that because of a lot of Wi-Fi, right? And nothing much to talk about it. And all those things, they're giving also same addresses, right? And they'll be sending an address back to the processor to say, hey, this address is a fire in this section, and whatever you need to act, or sending to the signal to the nearest fire brigade. So that's the fire monitoring systems. The four of them I just went through. Very easy, but just try and remember them, especially the intelligent one, because they normally ask questions on the intelligent one, how it operates. So each one is a processing unit. Each of the inputs, they have their own small processing unit, which can be able to sample the air to check for carbon dioxide or carbon monoxide, reduction in oxygen, because fire takes oxygen from the air, and that's why people faint when there's a fire, because oxygen is one. And believe it or not, it's the smoke that kills most people than the fire itself, than the burn. You see, so that's why they need to balance the mocks. This has to happen very fast. And now we're going to the next step, which is the fire suppression system. So the fire suppression system is a very good topic as well, which is, so you need to know how to differentiate between the two, the fire monitoring system, right, and the fire suppression system. So the suppression system, like it says, it can quench the fire, right? Not Zimamoto, right? That's the difference. And fire monitoring system, they don't switch off, they don't quench the fire. That's the biggest difference. But they can work both of them at the same time. You're going to see how later. The most common one you're going to meet a lot is called the wet system. So wet system, don't worry about a lot of things about it. I'm going to name each and every component step by step, and you're going to understand how it works. So the wet systems, all it means, there is pipes, sprinkler pipes, right? Same like sprinklers you have in a lawn or anything, right? They are all over the building, right? Where they want to control the fire in a data center, right? And if it's a wet system, that means they always have water. They are always loaded with water. You understand? They are always loaded with water. That's a wet system. Always loaded with water. So if by any chance Samba Mambara down the line is carrying a ladder the wrong way, and the ladder hits a sprinkler, one of the bulbs of the sprinklers, and the bulb breaks, it's gonna be water in the equipment, flooded water in the equipment. So that's why it's not a very good friend. But yeah, there's no stopping that water once you break it. You have to call the guys to come in. So the main disadvantage there is there's always water, and people may mistakenly break the glass and things can be flooded. So there's high risk of losing your data center. And it's going to be a disadvantage if another disadvantage, which is easy if it's in a freezing area, right? Whereby you're in UK, probably, yeah, Europe, where it freezes minus 20 degrees, or in Canada, down there, minus 15 degrees, minus 20 degrees, right? The pipe is going to freeze. So if fire starts, it's going to be ice in there, and there's no way of stopping it. That's why they brought the next one. But I'm going to go down a bit with this wet system. So the bulbs, there's little bulbs, long ones. I'm sure most guys, you have seen it in a lot of old systems. There's those bulbs that they put in there. So they all made with different chemical. So you have to check what type of fire are you likely to experience in your area, right? Or in your factory. Probably someone is making rubber, right? Will not have the same bulb with someone who is probably just picking sweets, for example, charons, right? You won't have the same, right? Different color. Someone who is running a boiler, right? It's always hot in a boiler room. So you can't have the one that is very low. So they all have different chemical inside the liquid, actually, that is inside, but it's very fast to heat up. So it senses the heat and it boils, then breaks the glass, then the sprinkler is released. That's how it works. So one thing for sure, it has to be different types of water in the sprinkler. That's one. Not water, actual liquid in the sprinkler, depending on where it is operating. That's one thing you need to note there. They're all made in different colors, and you just contact them, whoever is doing, or if you are doing a replacement, just check the next one, what color it is, then you order the exact same, right? They all color coded, just like the resistors, right? So it's very easy. And two, there is, remember we say there's fire, there's water, or always filled in there. So there's need to have pumps, right? And those pumps, they work in a very special format, right? And the pumps, you have the one, which is the main electrical pump, right? Which is not fed from any of your DBs in your building. It will have its own special DB, right? Which cannot be switched off in any way unless there's a fault, right? So for those guys that are in New Zealand already, that have done, or in Australia, that have done the regulation, they will see that there's a special code for this, for powering this pump. So you can switch off everything in the building, like the main breaker, and the fire pump won't switch off, right? Because it has its own special power source. And for that, remember, we're talking about redundancy. So for redundancy purposes, it will be operating with a diesel pump, right? So in case you lost power in the whole area, but there's a diesel pump, or in transformer blew up and caused everything downstream to burn down, you'll be still having a diesel pump, which is wired also in parallel with this petrol pump. So the diesel pump will take over. That's why there's the redundant. So you'll find redundancy everywhere in a data center, everywhere you look. So the diesel pump with its own tank, diesel, not connected to the generator, its own tank, was checked and tested every time, right? And that's it. But remember, so this is the biggest point. These are very big pumps. So in case there's a evaporation that happens, right? Remember, water can evaporate at any time, even though it's in a pipe. There's loss of pressure oftenly, or maybe there's a little leak somewhere. Water can be lost in some way. So it won't help to have that big pump. It's a very huge pump to start up every time to try and keep the pressure at the same level. It won't be possible. So what they did, they introduced a very small pump, which they call the jockey pump, right? The jockey pump is just there to keep the pressure constant in the pipes, right? The pressure reduces, it runs. to keep the pressure constant. So it will be running probably every, depending on how big is your system, it will be running probably every 30 minutes to an hour. Yeah, so most people, they recommend this pump, the jockey pump, to be under UPS, right? It must never fail at any time, right? And if reduction in pressure, for example, you have a fire there in one of the zones, or someone broke a glass by mistake by using a ladder, someone trying to fix a light and you get the ladder the wrong way and breaks one of the pipes, the jockey pump is going to think there's a fire, right? So it will try and keep up the pressure. If it can't keep up with the pressure that is needed there, then it will call the big guys. Guys, start. So the main one which will start is mainly the electric pump. Run and quench the fire, or run until someone who knows the fire system can come in and isolate it. But so you always have to remember that this is how you explain the wet system. So disadvantages are, once you break the glass, even by mistake, water is going to be dumped on equipment. 2, cannot be used in really frost areas, right? And because it can, the pipes can freeze and there's no fire, you can't switch off fire anymore. 2, another, which is the 3, which of the third one that I can think of, which are the disadvantages for this. But this is the most used, but the most efficient. So the advantages are, it's always there. So since it's always pumped with water, right, full with water, it's ready to take over. You see, it's ready to take over. To take over. So there's no waiting time to quench the fire. If a fire starts, right, that's the main advantage there. And 2, another advantage is it's water, right? Water, you won't need to. It's not a lot of money to spend water, but you may lose also equipment if you dump for mistake. So yeah, so the main advantage is it can cover big areas. It's right there on time to minimize the damage on equipment due to fire. Yeah. So now we go to the next one, which is the most common one. Remember, it's called the dry system, right? The dry system, all they do is, instead of having water in the pipes, now they have air, which is special air, right? Special gas, which is in there, or just say air. Sometimes it's special because you don't want, also air can freeze, remember, but the freezing point of air is very, very, very low, right? So if we install it in all those freezing areas, it will operate well because the freezing point of air is very, very low, right, of a gas. So they use that one. How does it work? So that one will always have a compressor, right, in place of a jockey pump. Always remember this, in place of a jockey pump, which is always running all the time to maintain the pressure. Here we have the compressor, right, that is always pumping the air to keep pressure constant. But now, then it will the same way have a diesel pump for water and the electric pump for water. So it's exactly the same. The only difference there mainly is it's dry system because it doesn't have water in the pipes. And in place of a jockey pump, in a wet system, in a dry system, we'll be having a compressor, which will be also maintaining pressure in there. So the main advantage of this one now is pipes won't freeze, right? And another one is second advantage is if someone breaks the glass, right, it won't discharge water. It will keep on trying to put the pressure and an alarm will sound and yeah, you see, it won't discharge. So, and that takes us to the next one, which is, I wanted to do this because let me do the fourth one, which is normally the fourth one in most presentations, but I'll do it on the third one, which is the deluge. The deluge, the only difference, it's exactly the same water system, but the only difference is if one breaks, right? If one of the bulbs breaks, sprinklers breaks, all of them will break. That's the only difference. It's a wet system, but it works like if in a certain zone, right, you are in room 1, and one of the sprinkler bulbs break there, all of them in that room will break. And so it will be damp with water. That's why I tell you. So that's the only difference. That's why I want to mention it now, because it's just a useless one. We don't really talk about it most. Right? It's used somewhere, but not that common. The one that you're going to be asked a lot is called the pre-action, right? So the pre-action one is a dry system, right? But it's wired together with a fire alarm system. You understand? So what will happen here is either of them, any of them, right? It will be wired at the same time. So what will happen is the fire alarm system will pick up the problem, right? A fire, most of the time, is the intelligent one, the intelligent fire alarm system. It will pick a fire, and you can set it in 2 formats to say, okay, once you see one alarm, trigger the water, or you need to have 2 at least to see smoke and you see oxygen reducing. That's when you can dump the water, you see. So they normally use it with the dry system. So that's the pre-action one. So this one you need to remember a lot, because it's just 2 systems that are combined together, so to achieve one, but it's normally a dry system. That's the pre-action one. So if you understood already what is a dry system in the wet system, now you know that it's a pre-action is just the monitoring system combined together with the dry system to achieve 2. So the main disadvantage for this one is it cannot cover huge areas, right? And sometimes fire is so fast that by the time 2 alarms comes in, or even for a dry system as well, normal dry system, by the time an alarm comes to say, oh, it's really a fire, it's not a mistake, probably a lot of stuff would have been damaged by then. So that's the 2 main disadvantages for the pre-action or the dry system. There's no water readily available to kill the fire right away. So this is the topic basically, and I've just went through it so fast because it's a very short topic, but you need to be able to explain the advantages and disadvantages like I was doing. So if you guys want me to explain more, you can always come to the group and ask me to add more material onto it. But some of the videos will not tell you, like I've just summarized for you. They will tell you one thing or the other, and you may not know where is all combining. Yeah. So the last one I'm going to mention to you is the one for gas. No water, but they use gas. So most of the time they use the CO2 gas, right? And that one is very dangerous. Yeah. So they are using now newer gases, types. You may research on the types of gases that they use, but they don't really care. Those gases are very expensive. So what will happen is this monitoring system will be wired together with the gas fire suppression system. So that one that uses gas. no one really talks about it that much because most data centers, they prefer water. They say we rather deal with water afterwards than to deal with gas, because gas, what will happen with gas? Gas kills. So if it dumps oxygen, if you can look for videos online about these gas systems, there's a lot of dangers that are in there, because even in a 4-meter by 4-meter room, if you're on the other side of the room, you won't be able to find the door no matter how good you are. So the main thing that you need to do there is just to lay down and try to crawl. Remember, you don't run out of the room. If there's a fire, you need to be able to crawl out of the room, right? So that's one of the things that you need to do. So the gas one is very dangerous to people, right? So what will happen if it's a pre-action alarm? So in a intelligent alarm, the monitoring system will trigger the gas, and within seconds, once it's triggered and you know there's a gas, if you see the bottle, it's easy because you see the fast bottles on the corner, big ones normally, you need to run very fast, drop everything, literally everything, because you die. So the gas system, but not really discussed many times. And if it's a mistake and someone triggers the gas by mistake, it takes a lot of money to fix it. So there's minimum damage to equipment, but there's a lot of losses that may come if someone dies out of the gas discharge. That's why a lot of data centers don't really like the gas systems, fire suppression system using gas. They use water. Most of the data centers that I worked in, they use water because it's effective, it's cheap, easy to maintain. So we'll talk about maintenance. So they normally check the fire alarm system is normally connected to the BMS, right? And it's checking all those, it's checking most of the, monitoring the pumps, bearings, schedules for maintenance, all that stuff. BMS is going to remind you on all those things. So it's linked to the building. And that's how the BMS is very important as well. The fire alarm system is also linked to the BMS, and the BMS is linked to the air conditioning system. Remember this, always remember this, guys. If a fire is detected, all the air conditioning equipment must switch off, because why? Fans will accelerate the fire. So the BMS now is the in-between guy who is going to switch off, send signal to switch off all the air conditioning systems, and send the signal to sometimes the fire suppression, fire brigade, and fire is going to be quenched. All dampers, all places to close to make sure that there's no more oxygen that is coming into the building, and so that the fire can be quenched. So guys, this is the topic for fire. I think I cruised hard enough to make sure that we can close now. And so the next topics will be easy ones like health and safety. I'll cover a bit of more topics in one week, but let's take a week this tomorrow a break, and probably next week is a break as well. Then we can do next week but one, but I'll update everyone. But if any questions, please reach out. I'm always here to help, guys. Also, if anyone needs me to go back to these topics, we can go back at any time. So reach out, guys. Thank you very much for your
Thank you.